No, sir.
So what we covered last meeting, I started to design of slabs. And I mentioned that your slab can be one-way slab or two-way slabs. We need to figure out what type of slab before starting if you decide to solve your slab with your hand, because each type will have a different technique to solve or to analyze or to design your slab if you decide to use your hand calculation. But if you are using software, it's not a big deal to find out what is the type of your slab. Is it one way or two way? This is what we will do today. Last meeting also, I told you that if your slab is one way, we can set up a minimum slab thickness that can guide you to assume the thickness of your slab. And we learned how to design one-way slab with hand calculation, how to draw bending moment, how to make your design, how finally to figure out how much steel reinforcement required. Today, we will talk a little about two-way slab, and then I will open the software. Two-way slabs, sometimes your slab will be with beams, sometimes your slab without beams. If you look to this photo and look to this one, we have two techniques for a slab, for two-way slabs. Sometimes we will provide beams between columns. I have a beam between each two columns. These four beams will create a panel, and you can put your slab here. So your slab is supported first by the four beams, and then the four beams are supported by the column. And that makes sense. This is the typical structure system for any slab. But in this case, your slab is called solid slab. Solid slab. Solid slab is not a common name, but mainly a slab with beams. The second case, which is a good case for architectural design, which is your slab is rested directly on the column without beams. If you look to the bottom surface of the slab, you cannot see any beam coming out from the slab, just one surface. In this case, the structure system is your slab is directly supported by the column. I believe this one is called flat slab. Flat, this is a common name. Flat slab means slab without beams. So we have two cases right now for the two-way slabs. Your slab can be supported on beams first from the four sides of each panel. We have a beam here, we have a beam, we have a beam, and we have a beam. These beams supporting your rectangle shape or rectangle panel or square panel of the slab. Then your beam is supported by column. In the second case of slab without beams, your slab directly supported by columns. Supported by columns. So I think, from my opinion, as a structural engineer, this scenario is stronger than this one. If you provide beams, it will be more stronger or more strong than without beams. Because can you imagine, the beams is very rigid, very strong to support your slabs. Then the beams is supported by columns. It's not a big issue right now, but for two-way slab without beams, the biggest issue for the slab without beams is this connection between the column and the slab is not strong enough. We can expect bunch. We can expect the column can break, can make a hole in the slab because the slab is very thin. So this connection between the column and the slab is not strong enough. against punch. So we can provide some adjustment, especially at the column slab connection. Sometimes we can provide something called a drop panel. Looks like in the real life like this. You have this column, you have this slab without beams. We don't have beams. So this connection is not strong enough. So I made the slab more thick at this location. So the thickness of the slab is more thick by creating something called a drop panel. You make the slab more thick at this location. Sometimes the drop panel is not enough. We can provide column head. Sometimes we can provide column head. So the slab is more thick and the column is more bigger. Can you see? The column is coming with a dimension. Before the connection, I made the column bigger. And I made the slab thicker. So I made this connection more strong. Can you see? You did not provide beams. We have another issue, which is the connection between the column and the slab, which is not strong enough. So we can overcome this issue by providing drop panel. This one is called drop panel. Sometimes we can provide also drop panel besides column head. So the column at the connection with the slab becomes bigger. This is the typical shape of flat slab, just a slab without beams. The slab rested directly on the column. Sometimes we have a concern about this connection, so we can make the slab thicker only at this location. Sometimes we still have issue, so we can make the column is bigger at this connection. And these are the three cases: without anything, with drop panel, with drop panel, and column head. ACI give us some guide to assume the thickness of your slab. The thickness, if you have two-way slab, if you don't have beams, this is a table I'm gonna use to assume the thickness of your slab. If you have beams, with beams, this is the table I'm gonna use to assume the thickness. We have different techniques to design two-way slabs. They are more complicated, and we need to do more calculation and more analysis using these tables, but I will not go through them because we have a very limited conditions to use this method. Most of the time, these conditions are not satisfied. So we are going to use the software. Keep in your mind, which is this very important, what is the main difference between this plan and this plan? You are a structural engineer right now, and you have to understand this point. This one and this one are floor plan. But if you look here, we have two parallel lines. Can you see? We have two parallel lines. Two parallel lines. And here we don't have these two parallel lines. That means we have beams in this one. We have beams between the column. We have a column here, and we have a column here, and we have a column here, and we have a column here. In between these columns, based on the given drawing, I have a beam, I have a beam, I have a beam, I have a beam. So the beams in the floor plan are defined by two parallel lines. If you cannot see these two parallel lines here, that means we don't have beams between columns. Even for the edge, we don't have here two parallel lines. We have the center line and we have the edge of your slab. But in here, we have two parallel lines. And in between, we have the center line. That makes sense? So be careful and try to think. For example, for your homework, I give you 2 problems in the homework. Question number 2, question number 3. You have to understand that for question number 2, this is a slab without beams. Without. This one is without beams, because I cannot see any 2 parallel lines. These 2 lines represent the plane of your beam. But in this one, no, this one will be with beam or with beams. Between each columns or between the columns, we have a beam. Between this column and this column, we have a beam in between. Why? Because we have 2 parallel lines. Why? Because we have 2 parallel lines. Why? Because we have 2 parallel lines. That makes sense? So this point is very important for you to understand. How can I figure out I have a problem with beams or without beams? I have a slab with beams or without beams. Just a reminder, if you look to your floor plan, you have to, the problem will not say this. I will not write this, but you have to understand this from the drawing. Does that make sense? You have to understand this from the drawing. I will start to solve one of the, probably based on the time, I will start with this problem of your homework. The first one, this is what I covered last meeting. You need to design one-way slab. It's one-way slab. But for this one, I'm going to use RisaFloor. I'm going to use the software RisaFloor. How to download your software? Go to Google and search for Risa products. Risa products. And one of the products is called RisaFloor. Once you get it, you can try Risa now. I think it will ask you to create an account. You can use your university email to create your account and download the software and start to set up the software. It's very easy. Once you download the program, you will have icon like this, install FL, RisaFloor. Double click, you can start your setup. Does that make sense? Once you set up your program on the desktop, you will have this icon, RisaFloor. Double click on this floor, on this icon, and we don't have a license, but on Canvas you can have the license. We have a license on Canvas, but at your home on your personal computer we don't have, so we can launch demo. Okay, the program will open and I will click here to create a new floor plan. I will select here concrete floor slab, and for now, this is slab for office building. For now, we can change it later. But I selected concrete floor slab. I selected office building. Okay, and I can cancel this window. That makes sense?
Yes, sir.
This one looks like Risa 2D that we learned last semester with structure analysis. I can hide up this grid from view, drawing a grid, can hide this grid. If you would like to show them again, go back to view, drawing a grid, you can find them again one more time. I can zoom in, zoom out, zoom in, zoom out using the scroll of your keyboard. I'm sorry, the scroll of your mouse. I would like to hide this drawing grid. If you open the first problem in your homework, we have a slab without beams. That's fine. We have columns. That's fine. And the columns are 18 by 18 inch. We have spacing in X direction, 22 feet, 22 feet, 22 feet, 3 times. So we have 3 spacing every 22 feet in X. In Y, we have also 3 spacing every 22 feet in Y. Can create these 9 panels. We can do this directly on RISA floor. We have something here called the project grid. If you open this one, project grid, and I can generate project grids. What I did, one more time. We have a window here with many options, We can use some of them right now. But I will start with the project grid, and then I will generate project grid lines, and I will write what I did here. In X, 3 spacing every 22 feet. In Y, 3 spacing every 22 feet. So I will write here, we'll cancel this one, and I will write in Z means, I forget to mention this, Z means the horizontal direction. X means the vertical direction. So keep in your mind, this is the direction of Z in RISA, and this is the direction of X in RISA. This is the default in the software based on the given axis Z and X here. So in Z, it will be 3 every 22 feet. In Y will be, in X will be also 3 every 22 feet. So generate, I will write here, in Z, I will write 3 every 22 feet. In X, which is the vertical direction, it will be 3 every 22 feet. Once you say apply, okay, and close this window, you will have the grid lines looks like exactly what do you have in your problem. That makes sense? So I defined in Z direction 3 spacing every 22 feet. I divided in X, which is this direction, 3 spacing every 22 feet. So we have 3 spacing, 1, 2, 3. Each spacing will be 22 feet. 1, 2, 3 spacing. Every spacing is 22 feet. Does that make sense? Very easy. In a second, whatever you have, we can do it. If you look to your beam, your floor plan, we have only slabs or slab. I think the thickness is given. It's not given. We can assume the thickness of this slab, for example, 5 inch. And these columns are square, 18 inch by 18 inch. Let's start to draw the columns first. So if you go to insert, we have columns, and I can define explicit shape with rectangular cross section 18 inch by 18 inch. Okay, apply. Then I can draw by click at each location of your column. Just click. Wait until this red point show up. Then you can put click. Click, click, click. Escape. if you look to 3D ISO means isometric. We have this little icon can show you the isometric of your column. If you click this little icon one more time and look to plan, PLN, you can go back to the plan view. So right now, I am done with the columns. I need to draw my slab. So from insert, we have something called here slabs. Slabs. I will define the thickness of your slab, which is 5 inch. Apply, I'm sorry, one more time. Insert, slabs, your thickness is 5. I will go back to draw slabs and then apply. I can make click at each corner of this slab. Then skip. I started to click at this corner, click at this corner, click at this corner, click at this corner, and I return it back to the first corner to make click one more time. If you look to the plan as an isometric and this render view, you can see the columns and the slab. One more time, click the render view. One more time, plan to go back to the plan view. Keep in your mind, I will not draw any beams based on the given floor plan. We don't have beams. We don't have beams. We have only columns and the slab. Anybody has any questions so far?
No, sir.
This topic is very interesting. I do recommend everybody to download the software and train yourself. This is the more best benefit from this course, how to use a software to analyze your structure building. I would like to define how much life load we have. You can find it here from here, but I do recommend it to insert loads, area load definition. If you would like, we can start with area load directly. But if you go to area load, RISA has default definition. If your building is office, go ahead and select office. Storage, go ahead and select storage. Public building, go ahead and use public building. If this slab is a roof, go ahead and use roof. So RISA automatically will define how much load. Do you remember how? Because based on the table 4.1 in chapter 4 ASCE, and I told you this last meeting, 7, based on the function of your building, we can define how much life load we have. For example, for the residential building, we can figure out how much life load do you have based on some conditions. If you have roofs, we have values for the life load. You can access, you cannot access, you can provide something on the roof, you cannot. So we can find out the life load. If you have office building, we can define which value of the life load. So RISA, once you select what is the function of your building, RISA can define the life load. Okay, I cannot find the function of my building in these 4 or 5 selections. What should I do? You need to go to insert loads, and then you can define your load. This one will give you the office, the life load equal 50. This value is given by kib per square feet. KSF means kib per square feet. It's a 50. You can adjust it, by the way. You can change it. If your office building based on this table is not 50, which is this one, it's 100. So you can go back to RISA and change this value to be 0.1. That's fine, no problem. You can adjust anything. That makes sense, but I will leave everything. Okay, my function of the building is not listed here. So I can come to the last row and then push enter. And I can define a new one called residential building. I'm not sure if I'm write it correctly, but anyway, residential building. Maybe, yeah. Residential building. What is the value of your life load based on this table for residential building? And looks like we have stairs or whatever. I'm gonna assume it's 30. So your value will be 0.03. That makes sense? Then I will close this one. And if you go back to insert loads, area load, and open these selections, you can find what you defined, residential building. That makes sense? Okay. And then I can define the load by click. Select this option, just click. Apply. If you click here, it's not working because we don't have columns and we don't have beams. So insert loads, we have different options. I can select the last option, point to point draw. I will draw, click here, click here, click here, click here, and click back. RISA can define the life load. If you look here, once you define the life load, the color of this life load is blue, not blue, but white blue. So, or light blue, it's residential. That makes sense. Sometimes we have a part is residential, a part is office, another part is storage. So you can define the life load for each part alone. By the way, we before solving, RISA will do it. RISA floor will do it for you. Load combination. We learned this during our course that we need to add dead load plus life load after you multiply each by a factor. This is the ultimate load combination, 1.2 dead load plus 1.6 life load. RISA will do it for you. Don't worry. If you would like to check spreadsheets, we have here load combinations. RISA did it for you and the other. We have many. For the strengths, dead and life, we have dead multiplied by 1.2, life multiplied by 1.6. These factors coming from the code. That makes sense? You can adjust them, but we don't need because they are correct. We are ready to solve your slab. I can click this little icon. So RISA will start to solve. We are focusing today on the slab. I would like to design my slab. This slab. So what is the bending moment on this slab? If you go to this little icon or F2, or I think from view, model display option, you have different way, F2 or from view model display option or this little icon. That makes sense? And I will look for slabs. I will select here slab. And I will select color fill. And I will select contours. And I will select MZ. And I will select strength dead and alive, which is the last combination number 4. And I will say, okay, I will have this contour line. That makes sense? I will show you how to read this color, but so far, this is the bending moment in the Z direction. If you remember from this little icon, I selected slabs, I selected color fill, I selected contours, I selected from here MZ. Actually, we have two options, MZ and MX. MZ and MX, both of them will work with me. MZ, okay, will help you to figure out the steel reinforcement in the Z direction, which is horizontal. Keep in your mind, the steel reinforcement in the slab, we have some in this direction and some in this direction because it's a two-way slab. So how to figure out this steel reinforcement if you are working with MZ, which is in the Z direction based on the software. If you would like to figure out this steel reinforcement, you have to work with MX based on the software. This is the direction for X. Does that make sense? So from RISA, we are going to use MZ and we are going to use MX. MZ will help you to figure out the steel reinforcement in X. I'm sorry, it's not in X, in horizontal direction, and the MX will help you to figure out the steel reinforcement in the vertical direction. One more time, if you go back, slabs, color fill, contours, and you select MX, keep in your mind, you have to select the correct combination, which is strength dead plus life, because we have strength dead only without life load. This is a case of loading. If you go back to first module, we have different combinations. One of them is dead load only, but this is not the case. We are going to use dead plus life strength. Okay? You will have different colors because the moment is not right now in X. Any questions so far?
No, sir.
Remember last meeting when I solved this example? The final conclusion after structure analysis and loading, we have the moment M ultimate. RISA will give you this value. How can I read these colors? These colors has a scale on your right. Can you see here? We have a very dark blue color, ranged from 0.7 until 10.3. And we have light blue color, ranged between 0.7 and 11.7. So looks like the highest value of your moment will be around 11.7 kb foot. Does that make sense? So these colors and these values represent the value of moment at any point on the slab. So please go ahead and see what color do you have. I don't care about the green color over the columns. I don't care about them. I will concern about the biggest colors, which are light blue between 11.7 and 0.7. We have a very dark, which is in between this area, between 0.7 and the negative 10.3. So we have negative and positive, up and down. So I'm going to use the biggest value, which is 11.7. So if your bending moment, M ultimate equal 11.7 kb foot. Can I design? Yes, you can. You have a strip with a width 12 feet. I'm sorry, 12 inch, which is 1 feet. And the thickness of your slab equal 5 feet. I'm sorry, 5 inch. I would like, this is your B, and your depth will be around 4 inch. This is your depth. So keep in your mind, RISA, I'm gonna use RISA for structure analysis. Structure analysis means loading, combination, and finally, what is the bending moment. Then I will use my hand calculation to do my design. So we have a strip, one strip with unit width, unit length, width, 1 feet. And the thickness of the slab, we assume the 5 inch. Then the moment on this strip equal 11.7 from RISA. This is a technique for design. We have another technique. I will cover it, don't worry. But so far, I have the moment, I have the strip cross section, so I can find out the M ultimate divided by phi B D square. Your value will be 11.7 times 12,000 divided by 3.9 times 12 times 4 inch square. I have a value equal 812.5. I can open my tables. Just a moment. And your F prime C 4,000 and 60,000. Here's the tables. $4,000 and 60,000, 4,000, 4,000 and 60,000. There you go, 4,000 and 60,000. What is your value? 812.5, 812, 812. 800, we have here 800, 811, 815. This one will be good. So the value after you check row minimum and row maximum, your row equal 0.0158. Row equal 0.0158. That makes sense? 0.0158, yes. Once you get your row, keep in your mind this row equal area steel divided by B time depth. The value of row 0.0158, value of D 12 inch, value of depth 4 inch. Then I can find out the required area steel for one strip. The required area steel will be 0.0158 times 12 times 4. I got 0.758 inch square. Based on the table, if you select your steel reinforcement, and I do recommend to use one of them, number 3 or number 4. Don't use something bigger than this, number 3 or number 4. If it's a bridge or maybe something very big, we can use number 5 or number 6. But for building, for office, for any normal building, number 3 or number 4. So let's see number 4. The area of one rebar of number 4 is 0.2. So if it's a number 4, I will need 4 rebars. Number 4 for each 1 feet. Because this width is 1 feet. So for your slab, this is, keep in your mind, we are talking about MZ, the steel reinforcement. This is MZ or MX? This is MX. This is MX in Y, in vertical direction. So in this direction, I need every 1 feet, I need to distribute 4 rebar number 4. This is coming from MX. If you go back to RISA and select here MZ, okay, I think you will have the same value, 11.7, because this slab is symmetric. Symmetric means this dimension like this dimension, so everything the symmetry reinforcement. So in this direction also, I need to distribute 4 rebars, number 4, every 1 feet. For each 1 feet, I need to distribute 4 rebars. This is the final design of your slab. Does that make sense? So
Yes, sir.
RISA floor will help you to do structure analysis. Keep in your mind, structure analysis is not a very small step. It's a very big, because you have to provide the loading, you have to provide the on weight of the slab. RISA will do this for you. And RISA will give you the final bending moment on the slab. Once you get your moment, your design is a very, 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 very short step. Just your moment, divided your moment by phi BD square, find your rho, find your area steel. You are done. Anybody has any question?
No, sir.
I will do, you can go through the RISA more in depth, but we have another results for the slab, which is the deformed shape. What you mean by deformed shape? I think you are familiar with this from engineering mechanics or from mechanics of material. If you have any beam or any slab between 2 support, if you stand on this slab, this element will deflect. You should expect deformation. This is called deformation. So the slab will move down a little bit. You can figure this out from RISA. If you go back to the same icon and the slab, and we have, sorry, not slab, deflection. I'm sorry, deflection. If you go to deflection and select this load combination, let's try the magnification factor is 40. Let's see. And this is one more important thing. I'm going to use the combination number 2, surface dead plus live. One of you will ask me, what is the main difference between surface dead and live, strength dead and live? For deflection, we are going to use surface based on ACI, dead and live. I can tell you, if you add dead load plus live load without any factor, this is called surface. And we are going to use this combination for deflection based on the ACI standard. But if you would like to make design, we need to multiply dead load by 1.2 and the live load by 1.6. And in this case, this combination is called strength. Dead and live. And this one is used for design. So if you would like to check or to figure out the deflection of your slab, you need only to add dead and live without factor. Just the values, the actual values of the load. But for design, you need to multiply this one and this one based on the ASC. So I will use surface, dead and live. Okay, you can see here the deflection of your slab. The deflection of your slab. This is the deformation. Can you see the original position of your slab? Is this line. We have deflection coming down. The slab went down. At your supports, at the columns, we don't have deformation. Still the same. But in between, the slab went down a little bit. You can read the values. It's in the range between 2.9 inch and 5 inch. You can actually put a range here. It doesn't work. You can make this one is bigger, maybe to show up. Yeah. It's a magnification. It's not the values, but just magnification. You are zooming in to show the deflection more clear. That makes sense? This is the shape of deformation of your slab. Okay, so we covered the slabs, color, contour, MZ, MX. We covered deflection. Don't look for beams. We don't have beams. We did not draw beams. We don't have any beams for this floor. That makes sense?
Yes, sir.
Let me repeat what I did. This is for the first problem in your homework. Not first problem, but the first problem for two-way slab. The problem asking to use RISA to analyze this slab. So you have to provide me with everything. How can I submit my homework? I think you are familiar with this, I believe. Let me go back to the undeformed shape. I think we can show up the yes. And also for slabs, we can yes. So we went back from the beginning. So you draw the plane. If you open a Word file, and you can write floor plan of question 2. You can go to RISA. We have something from Windows. It's called the snipping tool. And you can select from snipping tool, new, and make a window. I'm sorry. Like this. And make copy. Where is the copy? This one? No. Copy. I'm sorry. Copy. This one. And go to the Word file. Right click, paste. You can get it. And change it to be on front. So you can move it anywhere. Does that make sense? Then I can go back to RISA. This is for your information. I can show up the isometric with the column, with the everything. I can take another shot and the copy, go to the Word file and right click, paste. Does that make sense? You can make it in front. So you are showing me that you did the plan and this is the final sheet. Also from RISA, I will hide this and go back to the plan. I will show up the slabs, color fill, contour, MX, MZ first, ultimate or strength. Okay, this is the shape. That makes sense? So you need to take another shot and make sure you select this scale on the right. So I can understand the value. Keep in your mind, you need to select the scale on the right. Because if you select only this shape, how can I understand the value of the color? Does that make sense? Copy, and on the Word file, right click and put it here. Does that make sense? You can make it smaller, by the way. If you are feeling it's very big, you can make it smaller. And you can write here, this is MZ for steel rebars in horizontal directions. And the M ultimate from this one will be 11.7 kib foot. And if you would like, go ahead and make your design. You can write what you want. This is what we did for our design here. The value of M ultimate, and you can sketch and you can put your values and what is the value of rho, what is the value of area steel, what is the final design. This is for your X direction. That makes sense? For Y direction, I need to go back to RISA and show up the value of moment MX. Okay. And then I can take another shot like this and copy and put it here. That makes sense? I can say, I can write here. If it's very big, you can make it smaller like this. I can write here MX in vertical direction. The value of M ultimate equal 11.7 kib foot. And I can make my design. So if you look here, you are providing me with everything I need from question number 2. You have to show me that you defined your slab correctly. You have to show me that you defined the thickness and the dimension of the columns correctly. You have to show me the results on the slab in a horizontal direction and the vertical direction correctly. And you need to provide your design. You have to provide your design. This is what I wrote here for the horizontal direction and the vertical direction. That makes sense? So if you would like to provide me with the RISA results, don't give me the file of RISA. I need to convert all results from RISA to a Word file, then convert your Word file to a PDF file, from file, export, and create PDF file. Then you can submit your homework. Does that make sense? We have another example here for the homework. So I solved the 2 problems with you. The second problem or the third problem of your homework is a slab with beams, because we have the 2 parallel lines. I'm gonna use RISA, but keep in your mind, this dimension in horizontal direction is 2 spacing every 22 feet. And this direction, which is a vertical direction, is 17.5 feet. We have 3 spacing every 17.5 feet. 1, 2, 3. But this one is 1 and 2. So I will start file new. I will start from scratch. Click here to create a new floor plan. I will select the concrete floor slab. Okay. I will cancel this one. I will hide this grid. I think from view, drawing a grid, insert, drawing a grid, insert. If you cannot not find it here, insert, drawing a grid. For a horizontal direction, I can say we have 2 spacing every 22 feet. In the Y direction, I have 3 spacing every 17.5 feet. I can apply. Where is This is the origin. Draw grid rectangular. There you go. Because I did not ask the software to draw. Make sure when you insert drawing a grid and put your spacing and a number of spacing and the value, number of spacing and value, just to check this one drawing a grid so the grid can be drawn. So I draw something looks like this one. We have one here, one here, one here, here, here. So you can find out your panel. I think this information is not given. We can assume any cross section for the beams. For example, 14 by 30. And the columns can be assumed 18 by 18, like the previous example. And your slab, the thickness equal 4 inch or 5 inch, whatever. So from insert, columns, explicit shape, I can define 18 by 18. Okay. Apply. Then I can draw my columns. This is what we covered in the previous example. The new thing today, or in this example, beams. Insert beams, beams. I will select explicit. I will define the depth is 30 inch. The width is 14 inch. Okay. Apply. Then I can click here or just click between the 2 points to draw my beams. Does that make sense? Click. Here you go. If you would like to see it, isometric, this is your sheet. If you would like, you can take a shot from this shape when you are constructing your model and put it to the Word file. This is question number 2. I started in a new question number 3, I'm sorry. So you can put it here. Here you go. I can make it bigger or smaller. That makes sense? Keep in your mind, so far, I draw only the columns, I draw only the beams. So go back to plan, hide this isometric. From insert, we have, where is the slab? Insert, where is the slab?
It's not shaded. Yeah.
Yeah, looks like we did not select something from the beginning. Yeah, we have to select this one, concrete floor slab. This is very important. Okay. I can define the drawing a grid from here to spacing for every 22, 3 spacing for every 17.5. Then apply. Yeah, there you go. It's highlighted right now. Well, I'm sorry, I need to start from scratch. So the columns, explicit shape, 18, 18, okay, apply. For beams, we have explicit, your beams rectangular 30 inch by 14 inch. So I can draw my beams. Then from insert slabs, I can define out the thickness, which is 4 inch. I'm sorry. Insert slabs, 4 inch, and the draw slabs, apply. I can click at each corner. If you would like to show up the isometric, that's fine. From insert loads, if you would like to define the load, it's up to you. Area load, it's office. I will apply it, it's office, and I will select it point to point or just click. Let's try to click. Yes, we can click it. So if you look here, the blue color is office building. Spreadsheet, make sure you have the required combination. This step, just to check, and then we can start to solve. Keep in your mind, right now, we have beams. So if you show up your slabs, color, contour, MZ, strength dead plus life, this is the drawing of the bending moment. View, beams, you can. This is the bending moment. If you would like to read these colors one more time, this blue, dark blue, any point in this dark blue means your moment is ranged between 1.56 to 2.13 tip foot. Any point has a yellow color, any point on this slab has a yellow color, means your moment ranged between 0.72 and 1.29. So you can get the maximum value of moment, which is around 3 or maybe 3.57. And you can use this value to start your design. And this value will give you the moment, will give you the steel reinforcement in the horizontal direction because it's MZ. If you go back and show up the MX, okay, will give you a different color for the steel reinforcement in the vertical direction, this way. And the maximum value will be different, looks like it's around 2.8. So we have a steel reinforcement in horizontal direction coming from MZ. How much? I will use 3.57. This is the maximum value. So I can, M ultimate equal 3.57. I can start my design.